Hey all, this is the first chapter we're going to cover. Is about automation of manufacturing processes and operations. In this chapter, as you see on the right, we will be covering almost all the subsections except 37.8, which is flexible fixturing, but the rest subsections will be covered, and they are mostly about automation, as the name of the chapter implies. We'll be discussing the types of these automation methods, hard automation, soft automation, and also we'll be spending some time on numerical control, its fundamentals. We'll be discussing the type of control strategies, especially employed in manufacturing machineries like open loop, closed loop, and adaptive control. And to the end of the chapter, we'll be discussing industrial robots, what are the types of them, and we'll be also focusing on the type of sensors we can use in robots and also in some manufacturing systems. And let's quickly discuss the history behind manufacturing and automation. And until actually 1950s, we didn't have any automation in the manufacturing systems in manufacturing plants. The manufacturing was all done with labor, and we need to have skilled labor. So, and another thing is that the plants, the factories, the machines actually lacked flexibility. Since we don't have any computerized systems, you need to design actually machines which can only perform a specific task. So that's why in the earlier days we only had inflexible machines. They were just focusing on a single operation. But if you want to manufacture a new product, then you need to design new tools, deinstall and then reinstall such kind of equipment on the same machine to fabricate a new product. And obviously, this was highly inefficient, and that's why people tried to find some ways to make it automated, such production systems, and their main aim was to increase the productivity. And with the help of actually mechanization, automation, and control, now these days we have full control on the manufacturing plants. With the help of these technologies, these approaches, we have flexible systems, productive systems. In a short amount of time, we can produce high number of products. And another thing is that we can easily change the resulting outputs by modifying some of the software and some special tools. Mechanization is about actually eliminating the labor from some specific tasks. With the help of such engines, we come up with the term mechanization, and we make use of actually mechanical, hydraulic, and pneumatic tools. With the help of them, some hard tasks actually can easily be performed in the plants, in the machines. And then we have automation. As the name implies, once it's automated, then that means without any human intervention, the process can be completed itself. And another term here is the control. Even though it's automated, sometimes you may not have full control on your manufacturing plant or your machine. And control, we mean that you have some desired inputs and you want your machine to actually work according to these inputs. And if you don't have any control, then it may not be possible. But if you apply control systems, if you have an open loop control system or a closed loop control system, then you make sure that your machine will actually act according to your requirements, according to your specifications at the beginning of the process. And in this chapter, as I mentioned, we will be focusing on mostly on automation. And here is a schematic outline of the chapter. You see we have soft automation, hard automation. Hard automation is related with the transfer machines. And then in automation, we have different, let's say, approaches. We make use of robots, We perform assembly operation with these automation technologies. We can handle various kinds of parts easily. We have some type of control, since we said that control is highly important in automation. If you don't have control, then mostly it's quite difficult to have an automated system. In terms of control, we have manual control or computer-aided control kind of things. We'll discuss all these. We have numerical control. This is highly popular. We make use of computers to control our axis, our motions in the machines. And in adaptive control is a bit advanced version of the conventional numerical control. And this one, it tries to add some intelligence into our control system so that with less intervention, the whole process can be automated. So let's discuss the meaning of automation. With the help of this process, we are enabling machines to follow a predetermined sequence of operation with little or no human intervention. And this is a highly important issue in productive systems, productive plants, machines. And here you can see the history of automation in the manufacturing processes. Around 1800s, we actually start using, as you know, some kind of turning machines with the help of Industrial Revolution. And then until 1945, actually, we didn't have any automation. Most of the tasks were performed with huge, let's say, machines and labor. While after 1945, we have introduced the term automation. And this one, we make use of actually simple digital computers. They were not so complicated, maybe just composed of simple logic gates. But at least with the help of them, we started to automate some systems, some processes. And later, as technology actually improved in computer science, in electronics industry, we have more powerful computers and we introduced some industrial robots. And with the help of industrial robots and some other improvements in electronics, computer science, we now at around 1970s, we can do some autonomous kind of welding operations, especially in automobile industry. With the help of them, actually, the cost of these production facilities decreased and people start to actually buy such automobiles much easily. And then once again, artificial intelligence is introduced, some smartness, some kind of intelligence levels are increased in robots, in computers. We make use of them to actually make our manufacturing systems and machines more automated. And as you know, these days, we have much powerful tools like cloud-based computations. We have actually special software which are generating the machine codes directly. So these days, we have much more powerful tools and things are much easier to make all these automation processes, manufacturing process automated. And we can make use of actually this automation in various fields. We can use them for production processes. We can have automated process for handling materials. For instance, you may pick one piece from one point and then place it somewhere else. And these are all done with the help of automation. We can also make use of all these tools to perform some inspection. We can check the quality of the resulting parts and state whether it's okay or not. So then, depending on the result, your automated system may perform different tasks. Now we can even do some complicated, highly complicated assembly operations. We make use of mostly robots, some cobots or different industrial robots to do the assembly operations. And another important thing I would like to mention is we don't have a specific actually revolution. We cannot say that at this point we switch to level 2, level 3, but we can say that it's some kind of an evolutionary process. As technology improves smoothly, this is actually reflected into automation in manufacturing processes. So you see we have little improvements, but at the end, when you compare 2010 with respect to 1900s, we have a huge improvement. So we can say that throughout this motion, throughout this time period between, let's say, 1900s and 2000s, we have an evolutionary process, evolutionary improvement in terms of automation and manufacturing processes. Please make sure that you know the first, second, third, and the fourth industrial revolutions. This is a kind of a little assignment for you. Make sure that you check some web sources about these industrial revolutions. And we can briefly discuss the numerical control. The breakthrough is actually around 1980s. Since around these periods, numerical control was introduced in MIT, and they started using such numerical control methods on the machines, on manufacturing machines, and they actually started inventing some computerized numerical control of machines, CNC machines. And later, once the computer science improved, and we have much powerful software like design softwares, engineering and manufacturing softwares. We'll be briefly discussing all these: computer-aided design, computer-aided engineering, and computer-aided manufacturing software. And if you combine all these technologies together and use them in your factory, then we call them as computer-integrated manufacturing systems, since in every aspect of your factory, your plant, you are using computers. Now I will be briefly discussing some types of manufacturing systems. The first one is job shop. Then we have standalone NC production, manufacturing cells, flexible manufacturing systems, flexible manufacturing lines, flow lines, and transfer lines. So let's start from the first one. It's the primitive one, job shop type of manufacturing systems. It's a kind of a very small, let's say, shop where you have some general purpose machines. Like in our machine shop, in our department, we have a lab composed of several machines, and we don't have a specific order relation between the machines. They are randomly placed, and they are general purpose machines, which means that you can produce any product on these type of machines. For instance, we have a milling machine. You can produce square parts, rectangular parts. You can produce some parts having holes, chamfers. It doesn't matter. So we have high flexibility in job shop systems. But the thing is that we need to have also high skills of labor. Otherwise, you cannot produce such different kinds of products on the same machine. You need to have high skilled labor in job shop systems. Then we have another type of manufacturing system. It's called standalone NC production. Obviously, we are making use of numerical controlled machines. And once you have them, then that means you have little flexibility, but not too much. Again, you need to write some machine codes for the production of the parts. And you need to, again, have some experience in terms of these machines. So it's a bit better than job shop systems, but not as productive as flow lines. We will discuss them in a moment. These two, we can say that they are less productive. If you want to produce, let's say, up to tens of parts, these manufacturing systems are okay. But if you want to produce, let's say, 1,000 of the same part or 1 million of the same part, then these manufacturing systems are not the correct choices. Then we have manufacturing cells. These are a bit larger than the previous two. In these cells, we have cluster of machines. For instance, you may have a specific room. In that room, you may put a turning machine, milling machine, drilling machine, kind of a robot for welding operation, for material handling. And this is called a manufacturing cell. And we prefer to use industrial robots in between, maybe at the center, but depending on the capabilities of your cells, there may also be some labor around. They may be removing a part from one station to another station. Then we have flexible manufacturing systems. This is a bit larger than the previous three. In these, we need to make use of computers, obviously, in most of the stages. We have automated material handling systems. We'll talk about it in a moment. We have automated AGVs, automated guidance vehicles. They are responsible for carrying some parts from one station to another station in the factory, in the plant. So we can say that their productivity is higher than the previous ones, but its flexibility is less compared to the previous ones. Then comes flexible manufacturing lines. As the name implies, again, we have some flexibility, and in addition, we have lines. So once you have a line, then that means your productivity will be higher, since probably your manufacturing line is producing a single type of product. But the thing is that with little modifications, maybe with little software updates and little hardware updates, you can produce different parts on the same manufacturing line. But once you think about flow lines or transfer lines, they're not as flexible as the previous ones. We have less flexibility, almost no flexibility sometimes. But the thing is that this is a type of manufacturing system having the highest productivity. So if your focus is on the cost and on a single product, then you should construct a special transfer line and decrease your manufacturing costs. Let me discuss this figure. You see in this figure, on the x-axis, we have increasing productivity, and on the y, we have increasing flexibility. Let's have a look at the transfer line, the last topic, actually, the last type of manufacturing system we discussed in a moment ago. The transfer lines, as you see, it has the highest productivity, but the least flexibility. So if your main concern is the number of products in a shorter time, then you should focus on the transfer line. And then we have flow lines. This is somehow related with the transfer line. It's in between the flexible manufacturing line and transfer line. So this is something in between. I would like to focus on flexible manufacturing line. As you see, its productivity is again highest among the flexible system, as well as its flexibility is also higher. If you look at it here, its flexibility is as high as rapid prototyping facilities, 3D printers, but still its productivity is high, but obviously a bit less than the transfer lines. Then we have flexible manufacturing systems. This has very high flexibility, similar to the conventional job shop systems. But the thing is that obviously it has higher productivity compared to the conventional job shop systems. Then we have something in between, manufacturing cells, then standalone NC production. And obviously this one has less flexibility compared to the manufacturing cell. The thing is that in this one, we only have probably one or two types of numerical controlled machines. It might be a milling machine or turning machine. So you can only produce such kind of parts, but it's not as flexible as the manufacturing cell. Since in the manufacturing cell, even you can do some assembly operations. Then we have the less productive systems, conventional job shop systems and rapid prototyping facilities. In this one, we have some printers or other specific equipment to produce the parts in a shorter time. And obviously, their flexibilities are higher, since in the conventional job shop system, you have different types of machines. You can easily produce any complicated part. But the problem is that you cannot increase the number of products produced in the same time. So this productivity is less. Again, it's the same for rapid prototyping facility. You may make use of 3D printers, metal or plastic type of printers. You can produce any kind of parts, but the number of products will not be that much compared to the transfer line or other flexible systems.